Hello, this is Professor Ajim Sutar from Adiabatic College of Engineering and Technology, Kasba Boda, Kolhapur. Today, we are going to deal with the topic air pollution. Now, let's start. What is air pollution? Definition: air pollution may be defined as the excessive concentration of foreign matter in the air which adversely affects the well-being of individual or causes damage to the property. It also affects plants, animals and buildings. It may be injurious to humans directly or indirectly. Now let's see what is the composition of atmosphere. Atmosphere composition consists of nitrogen, oxygen, argon, carbon dioxide, neon, helium, methane, krypton, carbon dioxide, carbon monoxide and other gases. Majorly nitrogen consists of 78%. Next, what are the sources of air pollution? The sources of air pollution would be natural sources and man-made sources. Now, natural sources will be consisting of aerosols, microorganisms, pollens, volcanic ash and gases, radioactive minerals, etc. Man-made sources will be consisting of combustion of fuels like uh, com- combustion of fuels, industrials, thermal power plants, automobiles, agricultural activities, nuclear power plants, etc. Now let's move towards the next point, that is classification of air pollutants. According to the origin, can be classified as primary and secondary. According to chemical composition, the air pollutants can be classified as organic and inorganic. According to state of matter, the air pollutants can be classified as particulate and gaseous. Now let's see what are the effects of air pollutants. Effects on human health. The gases or the pollutants which are liberated into the atmosphere causes the following problems within the human beings, that are bronchitis and asthma are caused due to SO2 and NO2 and photochemical smog. Asthma is caused due to the pollens. Lead causes lead poisoning in lungs. Hydrogen fluoride causes bone fluorosis. CO causes death by asphyxiation. And radioactive elements causes cancer, shortening of lifespans, genetic defects, as well as the oxides of nitrogen causes eye and nasal irritation, respiratory discomfort. Next, the effects on trees and plants. SO2 causes bleaching of leaves, killing of tissues. O3 causes premature aging, suppressed growth, collapse of leaves. NOx causes suppressed growth and bleaching of leaves. Fluorides causes necrolysis of leaf tip. Ethylene causes leaf abscission and leaf epinasty. Pan causes suppressed growth, silvering of lower leaf surface. Now let's see what are the effects of air pollutants on animals. The air pollutant causes lack of appetite, rapid loss of weight, periodic diarrhea, muscular weakness, wearing of teeth and fluoride and death due to fluorine. Paralysis and difficulty in breathing is caused due to lead. Severe salivation, thirst, vomiting, abnormal body temperature and death in few hours is caused due to arsenic. Next, the effect on materials. SO2 causes corrosion. Acid deposition causes the damage to building materials. SO2, H2S and aerosol causes damage to paints and protective coverings. SO2, NOx and O3 causes damage to textile dyes and fibers. Ozone and pan causes rubber cracking. SO2 causes deterioration of leather and paper. Effect on glass and ceramics. And there is also damage to the objects of art and architecture. The best example is the deterioration of the marble of Taj Mahal. Now let's move towards the next point of a syllabus for curriculum, that is meteorological aspects. First, atmospheric stability and temperature inversion. Now what is this? The degree of stability of the atmosphere depends upon the rate of change of temperature of the air with altitude. Now what is this? First, lapse rate. The rate of change of temperature of air with altitude is known as lapse rate. It is also called as environmental lapse rate. Next, adiabatic lapse rate. It is called as ALR. The internal decrease of temperature with height which occurs in the rising parcel of air mass can be theoretically calculated by assuming the cooling process to be adiabatic, that is, occurring without the addition or loss of heat. This rate of decrease of temperature with height is referred to as adiabatic lapse rate, that is ALR. Next, now let's see the relationship between the environmental lapse rate and adiabatic lapse rate. If ELR is greater than ALR, this condition is known as super adiabatic condition, that is, the atmosphere is stable. When ELR is equal to ALR, atmosphere is neutral. When ELR is less than ALR, the condition is subadiabatic condition, that is, atmosphere is unstable. And when the atmosphere is unstable, the dispersion of the air pollutants is maximum. When lapse rate is negative, that is, there is inversion condition. Now this is a graph representing the ELR and ALR stability conditions. On the x-axis, that there is determination of temperature, whereas on the vertical scale the elevation, that is the height rise, is depicted. Let's move towards the next point, that is inversion. When temperature increases with altitude, lapse rate is positive and atmospheric condition is known as inversion. It is atmospheric condition in which a layer of warm air traps cool air near the surface of the earth, thus preventing the normal rising of surface air. Therefore, pollutants will not disperse in the air. Inverse is a frequent occurrence in the winter and autumn seasons. During inversion, the atmosphere is said to be stable. It results in more pollution. In this picture, you can see a representation of cooler air and warmer air. As we know, the warmer air rises up due to its less weight, whereas the cooler air, due to its high density, remains intact with the ground surface. Now, whenever the air present near the ground is cool, the infrared light rises up. Here you can see the cooler air at the bottom and the warmer air at the top. Now, what are the effects of inversion? In normal situation, the hot airs are present at the ground surface and the cooler air rises up as we move up. As we move up, the temperature goes on decreasing. But in temperature inversion, what happens exactly? The warmer layer or the inversion layer is entrapped between the two cold air layers. Next point is plume. It is defined as the path taken by the gaseous effluents emitted continuously from a specific outlet such as chimney or stack or vent. Now here you can see a pictorial representation of the plume behavior. Different plumes, that is the gases eliminating out of the chimney, and its path followed in the atmosphere. Let's move towards the first plume, that is looping plume. This type of plume has a loop shape and it occurs in highly unstable atmosphere when rapid mixing takes place. The high degree of turbulence helps in dispersing the plume rapidly, but here concentration may occur near the stack if plume touches the ground. Here you can see touches the ground. Here the loops are formed and which touches the ground. Next is the coning plume. It is cone shaped with horizontal axis plume. It occurs in near neutral stable atmosphere when wind velocity is greater than 32 km per hour. However, the plume reaches the ground at greater distances than looping plume. Also, concentration is less, but it persists longer than looping plume, as the picture shown. The plume shape is in a cone. Next, fanning. This type of plume is emitted under extreme inversion conditions. Under this condition, the plume spreads horizontally and is very little vertical, spreading for kilometers downwind. It disperses very slowly. As you can see, a horizontal layer of plume is passing into the atmosphere without any disturbance, as it is entrapped between two layers. Next is lofting plume. This type of plume is in the form of loop or cone with well-defined bottom. Lofting occurs when there is a strong lapse rate above surface inversion. Under such condition, diffusion is upward, but downward diffusion does not penetrate the lowermost layer and emission will not reach the ground surface. Here, the dispersion is taking in the upward portion. So the name is lofting or lofting. Next is fumigation. Here the pollutants are brought rapidly to the ground when air destabilizes. The plume is in the form of well-defined cone with graded, dragged or diffused bottom. Under this condition, the concentration is relatively high and the probability of ground contact is also very high. Here the dispersion takes place in the downward direction as the picture is showing. Here you can see the best examples, the live examples in the atmospheric stability conditions. This is a plume looping at 2 p.m. This is another example of plume. This is the plume lofting where the parcels are lifted up at 7 a.m. in the morning. Thank you.